front back up.
Like, what the hell? That's just so much.
You what?
Like, what?
No.
So exhausting.
Okay.
I don't like that.
So let's see what kind of questions we come across off of T, right?
Like, in the span of 2 days, 13 weeks.
Oh, look, there's all your pictures. Yay. What am I looking at? All right. T or U? U? T. What are we doing?
T.
T. Questions off T.
The last one.
What?
The last one?
Dude, I just.
21?
Yeah.
Yeah.
All right.
Can we do 13 after?
Yep. All right. On your quiz tomorrow, the last 3 questions are going to be this type of question. So let's move the 12 over. And then I'm going to get rid of the negative by just multiplying everything by a -1. If I do that, that sign flips over. So this is what we're going to base our information on now. Okay? So that says, hey, we want to find where this is greater than 0. All right, let's factor it. Now, guys and girls, if you're not able to factor these quickly, go back to the old thing where you're going to multiply -12 times 15. You get some big number and figure out all the factors that would add up to -11. But you might be able to do this. That might be 4, that might be 3. Nope. That's a 4 there. That's a 3 there.
One's positive
And one's positive, one's negative. That's 20. That's the negative, that's positive. All right. Little trick on the graphing and or on the factoring. I don't know if y'all know this. When we're doing this, it's going to be really rare that I have 15x and x. Really rare. Okay? And then, as far as factoring this, 12 has a lot of factors, yes? We have 1 and 12. It's going to be really rare if we use 1 and 12. 2 and 6, it's going to be really rare if we use 2 and 6. The 3 and 4 is the more likely. So the more likely our factors are close together. So 15 is a hard one to say because you have 1 and 15. It's really rare to use that, so it's 5 and 3. But the 12, the factors that are closest together are usually the ones that we have for you as teachers to go start factoring. So once you do that, then you just have to figure out the placement of it. So that one will work. That's a 3, and that's a 4. So let's figure this out. So that's -3/5, and that's positive 4/3. If we're going off of this, we want positive. So over here is positive, negative, positive. So we want values that are bigger. So I'm going to go from -infinity to -3/5, close parentheses, and then open parentheses, 4/3 to infinity. And again, that's your interval notation. You're not using the square brackets because you don't have the equal sign in there. Okay, Riley, what you got?
I don't get why you use 3 and 4 though.
Yeah.
Like, why couldn't you use 12 and 1? Because it's a -11x.
You're absolutely right, but if I use the 12 and 1, it would not, if I were to FOIL this, 3 times 3x is positive 9x, 5x, and that's -20. -20 plus 9 is -11. If you use the 12 and the 1, it would not have worked on the middle number. So the hard thing on it is indeed the factoring part. And there's something that we refer to as called the 90-10 rule. I don't know if it's actually truly 90-10, but it's usually the factors that are closest together, the ones that we're going to use. That we claim that's 90% of the time. Is it really? It's more often than it isn't, so that's where I go with on that. If you have a hard time factoring it, multiply those together. So I don't know what -12 times 15 is. and then you have the two factors, and you're going to figure out which ones add up to the negative 11 and factor by grouping. But we're trying to steer you away from that. The test or the quiz, I'm not going to give you something that intense.
Okay.
Cool? Yeah. Uh-oh. What do we got? Just a picture?
Yeah.
It's not for me? Oh, sweet. Cool. Okay. Olivia.
Uh-oh. Other one. Oh.
All right, what other questions do we have? I'm sorry, go ahead.
Can we do 19?
Yeah.
Maybe.
Number 19.
No, I literally, no.
I'm going to do this first. I moved that.
I
Zero.
literally like didn't know what to say.
Is that okay? I just moved that 10 over first. All right. So let's put into practice our 90-10 rule. So I'm going to go 3x and 2x. I'm not going to worry about the 6x and the 1x. Is that okay so far?
Yes.
Yes.
All right, we have alternating signs, so we know plus minus are going to have to fit in there somehow. Let's figure out what we're going to do. Let's do the 90-10 rule. Ready? Riley, you might see this one real quick. Ready? So that if we do the 90-10 rule, that means that my factors of 10 are 2 and 5. Agreed? Agreed?
Wait, say that again? Yes.
So but the 90-10 rule, the two closest factors are the ones that we're usually going to always use on factoring. So that's why we use the 3 and the 2x. I'm sorry I'm interrupting somebody. The reason I go 3x and 2x is most of the time I'm not going to have 6x and x as my factors. Most of the time, we say here create 90-10. 90% of the time, I'm going to have the two closest factors as that first term. Okay. Now, if I'm going to use that, that means I'm not going to use 1 and 10. I'm going to use 2 and 5. Now, let's use a little logic here. Would it make sense? I'm just going to put this here. Would it make sense to have the 2 there? Look at it for a second.
No.
Why not?
Because they're 2 and 2, and you're not allowed to.
Right. There you go. So it would not make sense to have the 2 there. It makes sense to have the 2 there and then put the 5 here. Okay. Bless you. So now we have to figure out how can we make those factors add up to be a negative 11. Well, if I put my negative here, that gives me negative 15, yes?
Yeah.
Yep. If I put a plus there, it gives me plus 4. It's negative 15
right.
minus 11, or minus...
Yeah.
Yep.
No, yeah, we did.
Got it. All right. So now let's try and factor it. So I have negative 2/3 here, and I have 5/3 here. I'm going to start on the right. This is positive. This is negative. That's positive. We want values that are less than, so I want the middle. So I'm going to use this. 2/3, comma 5/3. Okay? That's where our graph would be negative.
Is that it?
That's it. Done. Okay? So again, we're not trying to graph the whole parabola with this. I mean, you should be able to start seeing that this is what the parabola would look like. But we're trying to do it quicker because a lot of the stuff we will talk about that you'll get to in pre-calculus and calculus is you're talking about the one dimension of what the equations do, and not the xy dimension. Yeah?
Why would it be 5/3 and not 5/2?
It is, let's see, negative 2/3, 5/2. You're right. I'm sorry. Thank you for catching that error. See, you said you weren't getting this.
Well, I just read it. No, I don't get it.
15.
15? Yeah.
Yeah, right? Like, that's like all you can think is just out.
All right. So, the only way to do 3x is 3x squared is 3x and x. And then let's use our 90-10 rule. So I'm not going to use 4 and 1. I'm going to use the 2 and 2. And I think, let's see, 3x and that is negative 6x. Oh, what happened on this one?
Gotta be 4 and 1 with Michael.
Got to be 4 and 1, right? Where's the 4 go?
The 4 goes with
Goes where the 2 is. Okay.
4 goes with
the
X.
3. No.
4 right here?
Yeah.
1 right here?
Yeah.
So this one against our, this is our 10% rule. Okay? So this has got to be a negative because negative 12x. This has got to be a positive, positive 1x. Okay? So this one, we used the 1 and the 4. We didn't use the 90-10 rule. This is only 10% of the time that is going to happen. So then I get negative 1/3 here, positive 4 here. Start over here. That's going to be positive, negative, positive. We want values less than 0, so we're going to go negative 1/3, 2, 4. That would give us the negative component. Good?
How do you know, like, positive, negative, positive? Could it
So
be
if
negative,
this
positive?
if this right here on any polynomial that we'll graph is a positive number, if you start over on the right, the end behavior will always go this way. Okay? It might go this way on the left, depending upon what degree that is. But if you always start on the right, if this is a positive number, it will always be, the graph will go that way. If that was a negative, it's going to go this way on the far right.
In the middle.
And then the middle, so it's always alternating unless you have a double root. So if you had something that factored to, like, let's say it factored to this, and we want greater than 0. So this is just happening at -2. We start over here, that's positive, that's positive. I don't have a negative component in there, but I have one component that's 0. This component's 0 right here, agreed? So this would be negative infinity to -2, and then -2 to infinity. This says that, hey, we understand we have this positive, and we will start referring to this as a bounce. Okay, so you have bounce wiggling through. Okay, but a bounce means it was a double root, meaning it happened twice at that thing. If I had graphed this actual parabola, it would do this. Just like that. Okay? So that's what it would look like. Cool? All right. Will you do me a favor? Will you pass forward? Yes. Huh? Move the 49 over so you get 9x squared minus 49. Then it's 3x plus 7, 3x minus 7. It's difference of 2 squares. And you're looking for the 0, the middle parts. So negative, I can't do it in my head. So it's the middle part that you're looking for on that one.
So if the A is positive, then it's always going to be positive, negative, positive.
Starting on the right. If you start on the right, you're going to be correct saying that. If you start on the left, if you have things to the third degree graph looks like this. So this is going that way up. So we'll get there. All right, let's take out the review and let's talk about that quickly. Talk about the review quickly. I won't collect the review today because I want you to be able to review for it for tomorrow, if that's okay. Questions off of you. 12. All right. Number 12, they gave you an x-intercept of this, and then they gave you a vertex of this. Is that okay? Doesn't really matter I have an x-intercept. I'm going to use this equation. Y equals a x minus h quantity squared plus k. This is h, this is k, this is x, this is y. Is that okay so far? I'm going to plug everything I know into that equation to solve for a. So I'm going to get 0 is equal to a, don't know, x is -1 minus 0 squared plus -3. Is that okay? Let's take care of what's in here. That's -1. -1 squared is 1. So my a value is 3. So my equation is this. You could have this as just x squared if you wanted to, but that's fine like that. What else did you see on U? 7? 7? Two, and then x minus 5, x plus 3. Okay. I'm going to write it in standard form first. Means I'm going to multiply everything out. Okay? So that multiplied out is going to give me negative 2 times x squared minus 5x plus 3x minus 15. Combine like terms in there before you distribute. So you get that. Distribute the negative 2. So that's our standard form. Is that all right so far?
Yeah.
All right, then I want to put it in vertex form. So when I go to vertex form, I need to do this. I'm going to divide everything by negative 2. And I'm going to make a space. Notice how I adjusted the signs. Do you agree so far? Half of 2 is 1. 1 squared is 1. So if I add 1, I also have to subtract 1 from the same side. Is that okay? So if I got rid of like terms, that 1 and 1, 1 and negative 1 cancel each other out. So this is my perfect square. So that's going to be x minus 1 quantity squared minus 16. Multiply the 2 to all 3 terms. Plus 32. So that's my vertex form. What else? Go ahead.
Roman number 20, please.
20. Yep. An astronaut standing on the surface of the moon lowers a rock into the air with throws a rock into the air with an initial velocity of 27 feet per second. The astronaut's hand is 6 feet above the surface of the moon. On the moon, the gravity is negative 2.7. What is the quadratic to do this problem and find the maximum height? Okay, so this is 20. So my equation I'm going to use this is going to be I just spaced it. Okay, because normally we don't have that. So they tell us that the acceleration on the moon, gravity is negative 2.7. So we'll have to take half of that because the 1/2 sits there. The V naught T, the V naught is the initial velocity of 27 is V naught. So the T stays there, and he is 6 feet above the ground. So our equation is going to be this. And then plug this into your calculator to find the max, which is the vertex. I don't have my calculator open, but the x component is the time. The y component is the height.
Now let's start with the little like 0 at the end of that.
Just means not. It means initial.
Do we have to put it on?
No.
Okay.
No. This is just, in science, they use the knots. It's V at 0, H at 0, so where is it starting? That's all it is. All right. Can we put that away for a little bit? Cool. All right. I want to start out, and we don't have really long notes. What I do today will actually be due on Wednesday. Okay. I took a look at the quiz. The quiz, in my opinion, related to the last quiz, I think it's only about 40% as hard as the last quiz.
Oh, perfect. That's what
Meaning it's easier.
By about 40%. That's you're lying.
Shut up.
I am not. I am dead serious. I truly feel you all are going to do great.
Okay, you know what? I really don't. That's not. That's not my sophomore.
Mr. Stewart,
president.
do you have tissues?
Oh no.
Go on over the
Not the
rest.
first time I've heard that.
Who's the sophomore class president?
Yeah. Yes, it is a thing.
Please.
I was like, dude,
Stop.
All right. Everyone got notes? Did I give enough? Leave. Where are they?
It's Monday. Yeah, no one knows.
You got the slow people sitting in front of you. I'm sorry.
I'm doing fine. It's her. I'm doing so good. I got an extra hour of sleep. I'm an hour ahead of my daily schedule,
Gotcha.
so that's why I'm crazy. That's
All right.
all.
Let's do some notes.
I know that's false because you
So there's a
time change happens.
funny way that I teach this. I think you'll see the funny way when we get there. Okay. Properties of exponents. So raising something to a power. Okay. You've done this before, but let's go through this. So remember when if you have like bases and you're multiplying, you add the exponents. So this comes out to a to the 5th. Any questions there?
Yes.
So when exponents are next to each other, you count them up. When exponents are next to each other, you count them up. Okay? Does that make sense so far?
Yes,
All right.
sir.
That's going to come back on you. This is to the first power. You agree with that?
Yes.
So 4 times 3 is 12, x to the 5th. So again, when we're multiplying exponents, when they're next to each other, we count them up. We add them up. All right. Nothing outside. Let's see. Negative times negative is positive. C to the 1st, C to the 4th is C to the 5th. D to the 3rd, D to the 2nd is D to the 5th. This problem's done. Does everyone feel comfortable with that? If you have a letter sitting by itself, its exponent it's got raised to it is the first power.
Yes.
Good? Happy?
Yep.
Can I move on?
Sure. If you want to.
All right. So, what about when we do division? Well, if all of our exponents are all positive, like on the first one, we do tug of war. Who wins on number 4, the top or the bottom?
Top.
By how many?
3.
Into the 3rd. Good.
They're savage.
Okay? Number 5, we have a number in there, so we're going to reduce 10 over 2. 10 over 2 reduces to 5 over 1, or just 5. Tug of war with the x's. Who wins, top or bottom?
Top by 2.
By 2.
Oh my god.
Everyone set with that?
Yeah.
Yeah.
Okay? Number 6, I reduce, so I get 1 over 5. Agreed?
Yes.
I might not need that 1 there. If we leave it there, you're totally right. But some people are like, ew, you don't want to leave stuff there. It's
A
so
squared over 5.
tug of war, top.
A to the 2nd.
Tug of war, the B's cancel, no one wins.
Over 5.
A squared over 5.
A squared over 5. Or you could have 1a squared over 5 if you wanted
That's
to.
stupid.
Okay.
Thank you, Olivia.
Maybe it's just a different way of looking at it, my dude.
Sorry, my dude.
Sorry, my dude. So we have a rule? Nope, we don't have a rule. All right, so tug of war is basically the rule on that. If the exponents are all positive, that's our rule. We just do tug of war with it.
Cool.
Okay? If I have a number raised to the 0 power, if I have a variable to raise to the 0 power, the answer is just 1. Okay? If you have 0 raised to the 0, that's undefined. But x to the 0 or 2,000 to the 0 power or y to the 0 or a quantity to the 0 power, the whole thing's 1. If I have a negative exponent, it doesn't like where it's at. So right now, that's sitting like that. Agree? This means, hey, I want to move. So it doesn't really flip the whole thing. It just moves it down. Now, in this case, it does look like the whole thing did indeed flip over, and I totally agree with you. But it's moving to a lower thing, and we have to keep a 1 up there as a placeholder. Does that
You
make
just
sense?
don't want negative exponents.
We don't want negative exponents. They
But
keep.
you can have
Wait, Mr.
exponents
Sir,
at the
what's
bottom.
the rule?
Yes.
Perfect.
What was this rule for?
We didn't. Tug of war. Just put that.
Tug of war. Tug of
war.
Oh, no. Oh, war.
Tug of war. Okay.
Wait, tug of war.
Tug of war. Sounds good to me.
Tug of war.
All right.
Wait.
All right. For number 7, which part of that is 1?
C.
So that right there just gives me 1. What do I do with this?
You add them.
Put it on the bottom.
Move it down so I get c to the 3rd over c to the 5th. Agree? C to the 5th.
What?
Uh-huh. 1 over
Tug of war. Who wins?
Bottom.
Bottom by 2.
Bottom.
Done.
Can you explain that, sir?
Oh, I
Yeah.
get it.
All right. So this wants to move down, so it becomes a denominator.
Oh, it's a negative.
Then you have c to the 3rd, c to the 5th. C to the 0 is 1, so we're just not really worried about it.
But would it be?
Tug of war. Bottom wins by 2.
Why would it not be c to the 4th? Oh, because it's 0. Okay.
All right. This is the one that wants to move down. It's joined in the one that's already down here. So how many D's are on bottom? 5. I need a placeholder of 1 up on top. Done.
Cash, money.
All right. This moves up. It joins the other A. So how many A's do I have on top?
A to the
8
8
over E3.
A to the 8th. Good.
over.
E3.
This wants to move down, so E3. Done.
CP3P.
Is there anything about that that's tough? Anyone stuck?
No.
We're good? All right. This is 1, yes?
Yeah.
So what's the
The
answer?
third.
B to the 3rd.
Next one is just 18.
And then that's a 1, so 1 times 18 is just 18. Done with that. We doing okay on these?
Yeah.
Haven't gotten to the funny part yet.
Oh, that's what I like to use.
It's coming up. How many more slides I got?
1,
3?
2.
All right, we got plenty of time. All right. Okay.
Okay.
Ready? Remember when I said when exponents are next to each other, when you're multiplying the bases, you count them up. When exponents are next to each other, you count them up. You with me?
Yes.
So I'm going to tell you this. Exponents are like bunnies. You've seen a lot of bunnies out in the yards.
They
And
just
you want them.
multiply.
Okay, so if you're walking around your neighborhood and you're like, oh wow, there's a lot of bunnies, you just count them up. It's like multiplying the bases of exponents are next to each other, you count them up. But when exponents are on top of each other, they multiply. I'll let you figure out the thing with bunnies.
They make, they make funny
Is that
babies.
fun?
What do you think? Is that one okay?
Yes.
So this one, I got a negative outside. So this is going to say, hey, flip me over. Flip the whole fraction over. Is that okay?
Okay.
So this comes here, so I get 3 squared, which is 9, 2 squared, which is 4. Done.
Man, I'm sure the denominator wants to be
It's right.
like what the flip, man.
All right. So let's take care of this first. They're like bunnies, so they
Multiply.
They made.
multiply, but good
We're
try.
not Australians here, man.
Hey, what is that negative 6 going to do to the whole fraction?
That's a savage.
It's going to flip the entire fraction over. 2b over a. The whole thing's raised to the 6th power. Is that okay?
Yes. So it's
So then I get 2 to the 6th. I think I can do 2 to the 6th. 2, 4, 8, 16, 32, 64. So I get 64, b to the 6th, a to the 6th. Done.
I like this.
You don't subtract.
Spoke too soon.
Life good so far?
Why is it 64?
Because I got 2 to the 6th power. 2 to the 6th is 2 times 2, 4.
I got you.
Okay. If it's some other number, I mean, if it gets to be a ginormous number, leave it as that base raised to the exponent. But when it's raised to the 2nd, or the squares or something like that, you should be able to. All right, looks like we're multiplying. So a couple ways you can walk through these. You could say, you know what, let's reduce first. So 3 goes into itself once, 3 goes into 6, 3, or 2 times. Boy, if I could do arithmetic, I'd be much better. And then I could reduce, 5 goes in there twice, 5 goes in there 3 times. Looks like I'm going to get 3 over 4. Agreed so far?
Yeah.
I have 2 A's on top and a single A on bottom. Tug of war, who wins, top or bottom? Top by how many?
By 3.
By 1. So A or A to the 1st. This wants to move up. So how many B's do I have on top then if it moves up? 5? Done. So the negative exponent switched spots. It had to move up. And then number 16, deal. What did I do?
Bruh.
All right. This one, let's deal with the negative exponent at the end. So I'm going to get 2 to the negative 4, x to the negative 12, y to the negative 20. Agree? All of those want to move their spot. They want 1 to be on top, and then 2 to the 4th, 2, 4, 8, 16. Bless you. X to the 12, bless you again. So we get that. Any part of that you're questioning?
No.
And then write the expression for perimeter and area of the rectangle and simplify the expressions. All right, well, perimeter is 2L plus 2W, and area is equal to length times width. So P equals 2 times 2x squared plus 3y plus 2 times 3x squared. And the area is 3x squared times 2x squared plus 3y. Technically, you could probably leave it like that, but let's multiply it out because that's what they probably want you to do. 4x squared plus 6y plus 6x squared. Like terms are here and here. And then this one, distribute. 6x to the fourth plus 9x squared y. That's it. Was there any more? Am I done? One more? Okay. How are these different? I don't know. What is this, Sesame Street? Can I move off, or are we good?
Yeah.
And then we'll have time to go back to any of that last minute review stuff. And then I do have a small assignment that is optional, but I'll explain that in a little bit. So how are these different? Well, I don't know. That's 2 to the third, and that's x to the 6th. That's 8 over x to the third. How are they different? I don't know. You got a fraction in one and not the other. What do you do with the exponents when you have a power to a power? You multiply them. But we already talked about that. That's it?
Yep.
Wow. Okay. Dude, I went through quick. All right. So let's do this. On Tuesday, which is tomorrow, we have the quiz.
And you.
Okay? Wednesday, worksheet 6A will be due. That's what I just lectured on, okay? All right? So, I'm going to hand this out to you. There's 2 pages to this. This is optional. What does it mean when it's going to be optional?
You should do it.
It means that some of you don't feel that you did as well on the last quiz as you should have. Agreed?
Yes, sir.
So, if you do these 2 problems, which are not too bad, in fact, you have 7 minutes to get a good start on it, what I will do is I will, with both of these completed when these are handed in, I will increase.
You'll increase what?
Who needs one more? Read it.
I'll take one.
What will you increase this year?
All right. Everyone have one of these now? Eyes on this? All right. So you have a maximization problem of an area and a maximization of revenue. Okay? If you choose to do these 2 pages, which they shouldn't be too hard, you're making up your own problem. So let's talk about, real quick, a maximizing area problem. The max area problem is one of these. So you are a farmer. You have 200 feet of fencing. Still with me? Do not use my example. I'm not doing this for you. But you have 200 feet of fencing, and you want to create 3 pens, all the same size. Okay, 3 pens, yes?
Yeah.
So if you call the width is equal to x, you have x, 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 x. You have a length here, you have a length here. So your perimeter equation is going to be 2 times the length plus 4x. Okay? Go and solve this. Figure this one out. The max profit one, or the max revenue one.
How much credit do we get back if we do this?
Still thinking.
You said 10%?
Max revenue. This is one of the problems where it's like, hey, you owned yourself a bagel store. Okay? And so right now, you sell bagels for $1 each. And each day in your bagel store, you sell 1,000 bagels. So your max revenue is $1,000. Still with me?
I do.
All right. But some outside source comes in and does an advisement for you. Says, hey, if you increase your price of bagels by $1, you will increase your revenue. Which means you have your new equation, $1,000. You will so if you increase by $1, you decrease the number that you sell by 30. Okay? So then you create your revenue and you graph it. Okay? These are all problems we've done. If you choose to do both these problems, I will make these due Thursday.
We don't have to do them.
Up to you.
Extra credit, my dude.
If you choose to do these by Thursday and they're submitted on Thursday and not some excuse 3 weeks from now going, hey, can I go back and redo those? Okay, so this will be due by Thursday. I will add 4 points to your last quiz score.
What about the quiz tomorrow?
4%.
4 points.
What was it out of? How many points was it?
For what?
Let me see
4
what the girls-
percentage points or
Big.
4 points?
4 points.
Oh, okay, so that's
Clutch,
way better.
thank you.
What was that quiz out of?
I want to see what I get.
These guys playing spank and tickle with each other.
I see it. What was that quiz out of again?
I don't remember.
70?
I'll check those.
70 points.
Nice to my dog, please.
68 points.
Was that a 70?
So do you have to do this?
Yeah.
It's up to you if you do it or not. So what I'll do is once this is submitted, I will go back to your last quiz. I'll add 4% in. And I think it was worth 70 points, so
4%.
where's my calculator?
Why did you have to put them?
So those of you who only wanted me to add 4% to it, that's fine. This actually means that I add 5.7% to your quiz score.
I like the 5.7.
What if you guys wanted the...
No.
Will you round that 7% up?
No, you'd see it in there.
I actually turned
Oh.
in wrong homework again.
Oh, okay, cool. That's no biggie. Everyone happy?
Yeah.
Guys and girls, if you want extra help, you know when I'm off.
No, I don't have any options.
I'll be here after school if you want to. I'll be here after school if you'd like.